Today's CCNA term of the day is QAM, or Quadrature Amplitude Modulation, and that deals with how many bits that Wi-Fi can send all at one time, how much it can send in one symbol. The way QAM works is a lot like throwing darts at a dartboard. A moment ago, I threw a dart, and you saw that I hit a dot, one of 16 dots, and that dot represented 4 bits, because we can have 16 different values with 4 bits. 2 raised to the power of 4 is 16. Well, that would be 16 QAM. And by hitting one of those dots in what's called a constellation, I identified 4 bits all at once. I didn't have to send them one at a time. Well, how does Wi-Fi actually do that? Well, what it's going to do is use 2 different waveforms. There's an I wave, an in-phase wave, and there's a Q wave, a quadrature wave. And what we can do to specify the dot we're trying to hit is we can vary the phase. We can phase shift the Q wave, the quadrature wave, versus the I wave, and we can also vary its amplitude as compared to the I wave. And by doing that, we can specify a dot that we're wanting to hit. If you take a look on screen, we're phase shifting the quadrature wave by 225 degrees, and we're reducing its amplitude to 25% of the I wave, and that's going to give me a dot in that constellation that has a binary value of 1100. Now, I just used 16 QAM for easy visualization, but today's Wi-Fi standards use much higher levels of QAM. For example, Wi-Fi 6, it uses 1024 QAM. That's going to give us 10 bits per symbol. We send one symbol and suddenly we get 10 bits. That's one of the ways that modern Wi-Fi standards can send so much data, because as the silicon manufacturing technologies advance, we can have tighter tolerance levels for how many dots we can have in a constellation. And with 1024 QAM, we've got 1024 dots, and we can represent 10 bits by hitting one of those dots. And that's today's CCNA term of the day, QAM, or Quadrature Amplitude Modulation.